Greetings and welcome everyone to this 14th edition of Mydbops Open Source Database Meetup. And I would like to see a huge crowd of techies in front of me. I'm really excited to talk about our experience in various open source technologies like MySQL, Postgre, and Mongo and other technologies around open source databases. Okay. So today we are going to discuss about a transformative database journey for one of our client. This talk is mainly about not about the features and the solutions that we are going to discuss about. It's about how to implement the best practices in the database infrastructure. How do you maintain the servers? How do you observe the database performance? And how to ensure that the technology that you use fits your product requirements and that you make use of the technology the best, right? Yeah, this is a quick intro about me. I like open source technologies, and I used to do work a lot with open source technologies. I have 10 plus years of experience in handling open source databases, and I'm a certified MySQL and Mongo professional. So we started Mydbops in 2016 in a motto to support and cultivate that open source values to our clients, and to provide unmatched remote support, 24/7 remote support for operations as well as the consulting services. So we started then with MySQL. Later we expanded to Mongo, Postgre. Now we are partnered with dbms and AWS to deliver our services. So this is the presentation agenda today. Like, we will go over our case brief, like what is our client given, what is the client came up, subscribe for us, and how we audited their servers, and what are the key parameters we observed onto their infra, and analyzed it, and what are the challenges we faced during this observation, and how we transform the system in achieving the goal of the requirements of the client. So this is a typical case brief. Like, the client came to us to audit their database infrastructure to reduce the total cost of ownership, and they wanted MySQL upgrade in place, and they wanted to streamline their data model, because they had all the applications and database sitting on the same server. Okay, this may sound to be a simple use case. The scale of the problem was they were one of the biggest advertisement and marketing data provider or data feeder in the US market, and they had their servers running around 7 different DCs, and each DC were having close to 700 MySQL instances running parallelly. So though the problem seemed to be a little simple, but the scale is massive here. So here the important part is observability, like how you assess the system, and how do you understand what is the requirement and how we can scale it further. So all of these instances were running in 5.6, and most of the database servers, different applications were hosted on it together with the application. So as you may have said, right, like you have used PMM, you have used Datadog, you have used Sumo Logic, and various other open source monitoring system. The scale we operate on, the scale Mydbops operate on, will be difficult to fit into that, because the open source database monitoring system will be it's metrics, logs and traces, right? So basically these are the key things that we capture from any services, right? So these provide informative data of our system, right? And these data will be organized based on the components or the technology. The problem is that when there is a situation and when there is a need to troubleshoot, the navigation journey itself is a bit tedious, and you need a specialist to go over it. So based on our collective experiences and by utilizing the open source data platform like open source exporters, we have developed a monitoring system that scales to a number of clients for Mydbops, through which we can able to support the 24/7 remote operations. So that is BattleCat. So we had built based on our collective experiences, and we want the system observability system to be decisive rather than being informative. And again, it's built on top of the open source plus the custom exporters that we have built to capture the metrics. So when we want to consolidate any environment, right, for example, when you are having a huge scale of infra to be consolidated, there are a lot of things that can go wrong, because when you are running it in a very scale out environment, the things will be very much limited, right? Like whatever the downtime or the concurrency will be limited to the particular server that is being run, right? So we have to start investigate and record matrices across all these instances, like what is the real usage coming in, are the best practices of the database being followed here. Like the first thing I can see is the concurrency is different from connections. Like connections is something that a application makes a connection like TCP connection to the database. And concurrency is something what at any point of time the connections are actively running inside the database. So active concurrent connections and the overall connections. The overall connections matters because each connections carry a specific memory weight onto it. And the next important thing about consolidation is the bandwidth usage. Yeah, so because the scale is massive, that there is a very high chances that you will saturate the bandwidth and the query performance metrics, right? So things will break very rarely when you are running in a very scale out mode, because the amount of failure it can bring is very less. Like if one database node goes down and nobody cares, because that would be running in the same application server, and they can rebuild it, or they will have the additional servers which can come along, right? So when we want to consolidate or bring changes to the system, the important thing is that we have to ensure that system is fully optimized or thoroughly assessed and best practices are implemented. One more important thing is that the data volume really doesn't matter. What matters is the amount of active data that application want to be processing, right? So if you have even 2 TB data set, but if your active data set is just 200 GB, right, you can still operate efficiently within the given server's resources, right? So which is also one of the important factor that we need to understand, how the segregation, how we have to analyze the hard data that is being queried from the application. And you shall write several other OS metrics like CPU memory will be calculated for the observability in aspects of the consolidation, right? So we had around 700 plus application co-hosted along with the database, right? On each of the DCs, around 7 DCs, which is 4,900 database servers. And each application was connecting an average of 150, and concurrency was close to like some 15, 10. It's varying between 10 to 15. And at any point of time, if we can calculate the number of connection that come to the database from the application, we can foresee is somewhere close to 1 lakh to 1,50,000 connections per DC. The bigger problem I was talking about, like a bandwidth usage, is like the amount of data being returned from the query. Like around 10% of the data was returning around 64, close to 64 MB of data. So that's where the query performance metrics matters. Like what volume each query returning, or what kind of data it is returning, whether it is compressed or not compressed. So all these things comes into picture. So average and QPS metrics were collected also. Like the problem with consolidation again, right? More you consolidate, and you will be having a very lesser time to react. So that's the biggest disadvantage of consolidation. So the evaluation plays a key role on it, right? In a highly concurrent system, even a small query can cause huge disruption to the service. And one more biggest problem what we saw is that again the miss in database hygiene, right? Several applications started writing their own data to some of their replicas again, which is again the database anti-pattern. But yeah, so this was how the system where like when we started to engage, right? So when it comes to any technology choices, right? So we have to evaluate three important things, which is consistency, guarantees. Second thing is the performance requirements. Like say, what is the performance requirement you want, right? It's a 10 milliseconds, or it's 100 milliseconds, or what is the need of the application in terms of a performance, and what are the consistency guarantees and resiliency, right? In terms of a failure of any of the service or any of the nodes, how tolerable the database infrastructure is. And apart from all this, right, how fit it is to my product needs, right? So I don't want a fancy system if my requirement is very simple, right? Likewise, we can suggest like different solutions, but yeah, ultimately it has to fit to our application needs. So the choice of HA solutions, if we only focus about the MySQL, so we don't have a proper sharded architecture in a MySQL, like except the NDB cluster. NDB cluster is a separate in-memory thing, but in MySQL, if you take alone, all the MySQL solutions are shard nothing architecture based, which means that same data will be residing on all other nodes. It's a shard nothing architecture, they call it. So from the 5 series, that first few releases of MySQL, right, we have async replication. So then there is semi-sync replication where it added few more checkpoints to the general async. We will discuss about that, how it provides the consistency guarantees. And group replication is introduced in 2016 and followed by replica set in 20, which is again one of the other variant of async replication, but it's a little bit managed version of async replication. And in 2021, they have introduced cluster set, where multiple InnoDB cluster can be controlled and managed via MySQL shell protocol. And apart from all these MySQL's native high availability solutions, we have external plugin based solutions like Galera based solutions, which is from Percona ExtraDB cluster, MariaDB cluster. Here I haven't discussed about cloud based solutions or cloud based possible HA solutions, because the discussion was more about on-prem instances. And this is the traditional MySQL async replication, where the bin logs will be generated, all your writes is going to the bin log, and your slave pulls out the slaves pulls out the bin log and applies it. So this has no coordination between each other. And in semi-sync, they added an additional layer, like on receive or apply, it can send an acknowledgement back to the master saying that I have received it. Based on that, it can commit. It's like adding one more additional layer to that. And then came the InnoDB cluster. When we have received a talk from TiDB, they were saying that how they manage the consensus protocol, right? They used, TiDB used Raft and MongoDB uses Raft. And in MySQL, there is a consensus protocol called as Paxos being used, which is comparatively equivalent to Raft protocol. So this protocol in InnoDB cluster certifies all the transactions that's coming inside MySQL and coordinates the writes happening, so that the consistencies can be tunable, right? So here also I cannot say it as a synchronous, but the consistency is tunable from eventual to strict to various modes, as depends upon the performance that you want. Default consistency guarantee will be eventual, which means that as long as the the certification passes, it applies the transactions. And this is how the cluster set will be like multiple InnoDB clusters managed along with the help of the MySQL shell, which is introduced in 8 and later versions, right? Using that, we can completely control the entire InnoDB cluster across the various DCs. So this is possible. You can have a DRDC setup, and on the DRDC, we can elect and various primary cluster and secondary cluster can be decided upon. And the key thing that we wanted when we choosing the HA solution is to proper defining of RTO and RPO. So what I have seen in my experience in most of the cases is, right, we don't properly define the RTO and RPO, right? So I would suggest, if you are a database administrator or a product owner of any company and have managing databases, it is very important that you have a close track or a defined RPO and RTO processes, right? Recovery time objective defines, right, how quickly you can recover the data in the event of a failure, and recovery process objective defines how much of a transaction you can lose. As we see in our past, our goal was to achieve RPO, right, of 0, which is equal to 0, means that we don't want to lose any transactions, because losing transaction is the worst thing that you can have in your application, right? It can, you know, right, it can create a lot of ripple effects in terms of the customer credibility, in terms of the application stability and everything. The RTO should be in a matter of seconds. The election or the switchover of the role should happen in seconds. So based on all these considerations and the consistency guarantees, resilience and performance considerations, we chose to go with a group replication cluster. So group replication cluster can also be called as InnoDB cluster. The component is that InnoDB cluster and group replication cluster technically works in the same way. The only thing is that how it's being managed is being different. In GR cluster, as a DBA, we can manage the entire cluster promotion, everything. In InnoDB cluster, it can be controlled completely via MySQL shell protocol, and they have additionally, there is a load balancing component called as router. We purposefully not use InnoDB cluster since we wanted to use a different proxy solution for it. We will come to that later. So InnoDB group replication cluster is a native HA solution of MySQL, and which is being very stable in 8. Like it started its first GA release in 2016, and it's been evolved so much now. And 8 series in MySQL is completely, the feature of the MySQL 8 series is completely done now, and 8.0.34 is the version that MySQL has freezed now. Any version beyond that for the next 1 year will be the bug releases only. So I would certainly, if anybody wants to try out the HA solution for MySQL, I would strongly recommend to try out the group replication or InnoDB clusters on your needs. And I spoke about the tunable consistency already, and yeah, so it is the whole system of this HA is completely built based on the binary logs and GTID replication. So the core component of the transactions, when we compare to other plugin based model, this MySQL's native clustering solution will be much effective. So when we have a huge set of nodes to serve the traffic, we need a proper database aware load balancers, right? What are the current solutions that is available in the market, right? So we have MySQL router, which is from Oracle, and we have MariaDB from MaxScale, and we have a ProxySQL, and this is a separate company altogether. And we have a HA proxy, and there are various TCP and DNS based load balancing. There are a number of TCP and DNS based load balancing. There is, I don't want to quote anything in particular. Okay, so why database aware load balancers are important, right? So because database can come with its own set of challenges where we want to have specific requirements, right? So by deploying a proper load balancing solution which has the database awareness, we can achieve many things like user-based routing, schema-based routing, regex-based routing, query caching, which is again TTL based, and awareness to the underlying database technology that we are using. It can be either Galera cluster, it can be either group replication cluster. And the ability to distribute the traffic on a weighted based, or how you want to distribute your traffic, application traffic to the backend DB can be achieved by selecting a proper database aware load balancer. So based on this all careful assessment and the requirements that we had chose PostgreSQL. The one more reason being that we got a questions when the TiDB session was happening, right? What is the level of infra that we need to support any particular workload, which is very important, right? We cannot simply recommend anything. See, if you're asking about, say I want to scale X number of connections or X number of concurrency, right? We cannot blindly provide suggestions. So we want to have a quantifiable measure how I can provision my resource to support my workload, right? So PostgreSQL gives us that confidence, and based on our rigorous testing on it, like how much QPS or connections that we can expect it to handle efficiently given per CPU. Okay, so which is a important thing I would say, because if you don't have the consistent results based on the resource and the output, it is very hard to choose any particular solution. And PostgreSQL comes with own added advantage like runtime configuration adjustments, and it provides query related stats like it collects, since it's being in a middleware, like middleware between your application and the database, it captures the in and out of the connections, right? So it has the latency recorded in itself, like we can have the query stats recorded in itself, and those will provide a vital information to the application. So the major reason we wanted to use proxy is the connection pooling and multiplexing and audit logging. In our evaluation, we identified, right, we wanted to serve around like 1.5 lakhs of connections, again, which is subjective, because we didn't recommend that you need to have that many number of connections, but again, every conversation with the developers will not go as we planned, right? They will have their own mindset in terms of the response that is they're getting, because as a database admin, I can pinpoint to a single query and say that this is the latency for it, but as an application owner, unless they have proper APM implementation done, they cannot measure that latency or the where the time being exactly spent, right? So we wanted to have audit logging, we wanted multiplexing to reduce the number of connections that's going to the backend, because as the connection numbers increases, the backend maintenance work the database has to perform will increase, which can eventually lead to slowness in the workload. And this is how the connection pooling work in PostgreSQL. Like PostgreSQL maintains two separate pool of connections between the application to proxy and proxy to database. So this helps to reduce the lot of incoming connections that is being going to the database, and it intelligently does the multiplexing and connection pooling. So we feel that it is the best use of technology, right, for the particular given use case. And to speak about the challenges we faced, the client were using various database engines, and there were a lot of issues in schema, scarcity, and collations. As we talk about, it's an upgradation from 5.6 to latest version, which is 8, right? Here, the major problems comes in the collation support, because in UTF-8 MB, in MySQL 8, it's UTF-8 MB4. In 5.6, that is not available. So the collation, char sets, to replicate seamlessly, these are the very important characteristics. And bandwidth saturation we have received, because there were huge volume of data is being returned for single query. And when we want to consolidate, it can easily saturate the instance, right? And there are a lot of connector level issues which was created, like, see, connector can do a lot of things, like for its basic health check, by just pinging select one or selecting system variables or MySQL related variables, right? These are some of the issues that we foresaw during our analysis. And the major problem to migrate to cluster was the cluster fully works on GTID, where the whole infra, like around 4,000 plus servers, are all running without any GTID based solution. So we don't want to disturb the production or touch the production or gain access to the production and do a lot of stuff, because it's already a operationally heavy system. By changing something means, right, it has to be applied across all the whole 4,000 or 5,000 servers infra, right? So some of these issues like database engines, schemas and char sets has to be fixed up on the source itself. Like some of the schema changes, we cannot take it at the last, right? We cannot take it to the new setup, right? So those schema issues, char sets, collation and multiple database engines were all converted to InnoDB after evaluation of a lot of other stuffs. And there were a lot of databases which is being created and used by application onto the replica. Again, we have to move them to the cluster environment. So we had 5.6 with GTID off. So to replicate to MySQL 8, it's not a seamless journey, because when the GTID is on in the source, when we want to off in the source and we want to turn it on in the replica, it is difficult, and it is not possible before 8.0.321, which is the release which brought us a feature to allocate the GTID during the replication itself, right? But the problem with that was we had only that option was compatible with MySQL 5.7. Okay, again there was a blocker, and then we have to create a chain of data pipeline to replicate from 5.6 to 5.7 and 5.7 to 8, where we can replicate and assign GTIDs. Then we have to replicate back to the cluster. So all these challenges we have to take care to ensure our high availability is ensured during migration, and this whole activity has to be completed in a single downtime window. So this is how the auto local GTID creation will work. Like when we have a 5.7 master, right, it writes the log. When it is being replicated and its own bin log is being written, it writes the UUID of the master, UUID of the local server onto the binary log, and it says that the origination is this server. So that is the variable that is introduced in 8.0.21, which really helped us in achieving this migration. Without this feature, it could have been a very difficult journey for us. So post this overall migration, we were able to simplify a whole architecture that they had with a 3-node proxy SQL cluster and 3-node group replication cluster, and like around 5 to 6 other replicas, right? So those applications which required consistent reads were pointed to the group replication cluster through the proxy SQL, and those applications which doesn't require the consistent reads were directed to various other replicas in a weighted algorithm. So that is the power of the database aware load balancer. You can able to decide and direct the incoming traffic to the required resources that you want to point it to. So what is the infra savings we have achieved, right? So from overall 3,500 to 4,000 servers across DCs has been consolidated to 10 to 15 servers per DC. Again, depends upon the use cases. And we were able to successfully upgrade the end-of-life MySQL to MySQL 8, which comes with a lot of features on its own, and it's a separate talk altogether. Like what is the features in MySQL, like be it a clone plugin, auto provisioning, automatic tuning of MySQL 8 based on the dedicated server, and instant algorithm where you can do perform schema changes instantly. Yes, there are certain limitations like what can be done or what cannot be done with the instant. And from an unorganized data platform to a simplified data platform, and where we didn't had any HA defined, right? If you have async replications, you can use replication managers like Orchestrator or MHA, right? Or if you want to have a similar version, like you can use replica set, but here we can able to achieve our defined RPOs and RTOs, right? So that's the important thing here. And the overall operation complexity to manage the whole DB infra is completely reduced here. And so the application servers which are still there and have to be retired. So overall cost estimation is close to somewhere $1 million we have achieved per year. And what are the key takeaways from this? Like in Outlook, it may seem that simple migration from MySQL 5.6 to 8, but the scale varies depending upon the client and the requirement that you have currently. So it is very important that you audit your database infra regularly in various aspects, right? In terms of scalability, in terms of how the database is working. Like your data may be growing and you will be thinking that sharding may be required, but your active data set may remain the same, right? So it is very important to understand the your database problems thoroughly before going ahead with the solutions. So based on our analysis, not only in this kind of a ad or marketing based infra, like we have worked in the gaming, we have worked in the financial sector, we have worked on e-commerce platforms, where we able to bring their radical change in their performance, right? And simplification of the infrastructure and cost reduction, right? So it is always wise to scale with technology upgrades, right? What demands is there in your application. If your application is really demanding the sharding, and you can have a different platform altogether, like TiDB, CockroachDB, like UAByte, like various sharding mechanisms are available, right? And if you don't if the application doesn't demand that technology, it is not necessarily to use any particular or bias towards any technology. So it's always better to scale with technology, not with your credit card. And always ensure your database observability. Try to understand the product you have, curate depending upon your application needs, and always test your failure and backups, right? Most common case what I see currently is that backups are not being tested, right? It is always very important to test your backups to ensure that backup is in a state that is recoverable. And system failures are inevitable even in database managed services platforms like Amazon RDS, Aurora, where we have seen outages because of the system failures in the underlying hardware. Okay, so and I would encourage to define RPOs and RTOs for a database. And the reason we have chose this talk is that again, MySQL 5.7 is going to go end of life by this month, like 31st October 23. So plan your upgrades efficiently. And as I told earlier, the features releases are freezed in the MySQL, and 8.0.34 is the complete feature release for MySQL 8 series. And the next 1 year, only the bug fixes will be happening. So feel free to upgrade, because there won't be any new features added. Because if you see in the MySQL 8 series, there were a lot of additional features that's being added in each and every minor versions. So those will not happen going further. So you will get a stable and efficient MySQL release. So thanks for attending this session. And if you have any questions, we can discuss.